come and study with Tanzania Institute of Education.
Our study of coordinate geometry begins with the Cartesian plane, which was invented by a Frenchman named René Descartes in the 1600s. There is a story which is often told about how he discovered the Cartesian plane, but it may be a myth. One day, while lying in bed, he noticed a fly crawling around on the ceiling. He puzzled over how he could describe the exact position of the fly. He realized that he could describe the position of the fly at any single time, just by giving the distance from the two walls of the room. And this is the story of how Descartes discovered coordinate planes, which is also called the Cartesian plane in his honor. Let's look at how the coordinate plane shows position. By now, you should have learned about the basic or counting number line, and also been introduced to zero and negatives which extend the number line. Moving to the right is shown by positive numbers, and moving to the left of zero is shown by negative numbers. We can give position and direction, but in one dimension only. Descartes' idea was to put two number lines together, crossing each other at zero. The y-axis is the vertical axis, and the x-axis is the horizontal axis. The origin is the point where both the x value and the y value are equal to zero. The axes intersect here. The origin is the beginning or starting point. The coordinates for every other point are based on how far that point is from the origin. The two axes divide the plane into four parts. We call these the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. The vertical line running through the origin is the line where x equals 0 at every point along the line. This line has the equation x equals 0. The horizontal line running through the origin is the line where y equals 0 at every point along the line. This line has the equation y equals 0. So let's move 2 units horizontally away from the origin and 3 units vertically away from the origin. The place at which these 2 points intersect or cross one another helps us to show position. This means that we can use any 2 points on the horizontal and vertical axes to give a precise position. We call these 2 points an ordered pair of numbers or a coordinate pair, and to show them mathematically, we write them in brackets. The x-coordinate is always the first number in a pair, and the y-coordinate is the second number. The x value is also called the independent variable or the abscissa. The y value is also called the dependent variable or the ordinate. So let's try and locate some objects on this plane by giving the coordinates of each. Let's start with the first quadrant. The chicken is in line with 14 on the x-axis and 8 on the y-axis. Its coordinates are therefore 14, 8. The cow is 18 on the x-axis and 4 on the y-axis, so its coordinates are 18, 4. Then the second quadrant. The crow is at -8 on the x and 6 on y, so it's -8, 6. The tree is -18, 4. And on the third quadrant, the bicycle is at -6, -8, and the farmer at -16, -6. Finally, in the fourth quadrant, the farmhouse is at 8, -4, and the tractor 12, -10. If the farmer started at his position A and then walked to check on the chicken, B, and the cow, C, before picking up his bicycle, D, and taking it back to where he started at A, we'd be able to draw line segments to join the points. We can plot real-life information on the coordinate plane. Each point has 2 variables, x and y, so when we plot a point of data, we also plot 2 variables. For example, we can plot points showing the height of a child and the child's age. Let's look at an example. Prisha is 2 years old and her height is 70 centimeters. Arav is 4 years old and is 90 centimeters tall. If we got and plotted the data for another 13 children of different ages, we get a scatter diagram that looks like this. Each point represents a different child. So what does the diagram show us? Although we can't see a relationship for only 1 or 2 points, when we plot many of them, we can see a pattern emerging. The height increases as age increases. If we see a pattern in the points on a scatter diagram, we say there is a correlation. A positive correlation means that as one variable increases, the other one increases too. A negative correlation means that as one variable increases, the other variable decreases. If there is no correlation, there is a random arrangement of dots and we can't see any pattern emerging. If there is a good correlation between two variables, you can draw an approximate straight line to show the general pattern that the points seem to follow. There should be the same number of points on either side of the line. The aim is not to draw the line on the points, as it needs to represent all of the data. Let's look at another example. What information does this graph show us? There is a negative correlation between life expectancy and the number of cigarettes smoked per day. In other words, life expectancy decreases as the number of cigarettes increases. So the line that fits best looks like this. The line decreases from left to right because of the negative correlation.